Hello, my name is Koray Tuğberk and I'm the owner and founder of Holistic SEO and Digital. In this video, we will be talking about importance of entity attribute value architecture or the data structure and how we can actually choose the right attribute with the accurate values from the text. First of all, I have to tell you that when it comes to the semantic SEO, it might look like we are just having these trainings or free and pre-training for our semantic SEO course in terms of semantic search engines, but I can tell you that when it comes to semantics, it is about how we think. So I would like you to actually think all this training as a brain exercise, because if you are able to create a proper document just for semantic search engines by processing all the possible entities and all the possible attributes connections with the proper order and the comprehensiveness and the accuracy, and by using the right sentence structures, it means that actually you know how to think. Semantics is about how we think, linguistics is about how we express them or how we give shape or a kind of architecture to the meaning or the connections. So I can tell you that I have lost 3 days this week just because of the migraines and some vicious cycle. Migraine distorts sleep, sleep distorts or causes migraines. So that's why I am a little behind the schedule. But in the Q1 of 2023, we will be seeing the course have been launched. That's why I will suggest you to actually check directly this specific newsletter from Get Review. Soon I will be moving out from the Get Review and we will be having another service provider. Right now we are over 4,000 people here, but I believe the actual number is very much more with the people that are not subscribed to the newsletter. But if we include every channel that we have, probably the actual number is even more than 15,000. And once we actually create our own community, you will be able to help you each other. And I will suggest you to watch all these videos, because every video that I publish here, they are all connected to each other. If you don't watch Query Semantics, you won't be able to get actually SaaS SEO case study that we publish here, which also use AI. And most probably when I publish this video, there will be one more here, which focuses on the predicates, especially these 3 videos, this one, and the one that you will be seeing here that focuses on the predicates, and the one that focuses on the topical maps here. These 3 videos are highly connected to each other, and they explain actually semantic search engines and semantic SEO or semantic search engine optimization from 3 different angles. One is topical map expansion, the other one is predicates, or how we can actually use the predicates for further, let's say, relevance and the context optimization. And the last one we'll be focusing on, this, which will be focusing on the attributes mostly. So one of the mistakes that all the SEOs do is we all focus on entities. And I can tell you that these entity focus, it is a little bit too much. In fact, we should be actually focusing on mostly and mainly to do attributes, because attributes are way much more important than the entities. And usually the people they check what entities appear here and what entities appear in this page, and it is not about actually including or putting more entities to a single web page. It is actually about putting the right entities. If you just put too many or too much entities into a single web page, you will be diluting the context, and the web page will be relevant to the too many things that are not placed into that specific index. When it comes to the search engines and entity indexing, I can open my visual expression tool, which is Paint, the easiest tool to use in these videos. Let's say these 3 things are different indexing shards, and in every indexing shard there will be different query networks. In these query networks there will be different entities, and between these different entities you will see that different attributes exist. And with different attributes here, different contexts will be connected to them, and also different user clusters will be connected to them as well. So while creating actual topical maps using predicates or the triples, or let's say using subject, predicate, and object data structure, it is highly relevant to the actually object attribute value or entity attribute value data structure as well. If you are able to use these things in a proper way, you will realize that everything will be actually way much more, let's say, obvious for all of us. So let me just try to handle this specific video by explaining this logic here, how to choose the right attribute, and how we can actually arrange our contextual vector or contextual flow and also contextual coverage So let me explain these concepts easily too, because in the course these will be expanded further. But contextual flow means that from where you start your content and where you end it. And I call this thing contextual vector. And if you want to create a proper semantically optimized content, have a single and straight context. If you include too many entities, it will be distracted and it will go like that. That's why I tell this is about how we think. By the way, due to the migraines, I couldn't shave myself, so sorry for this beard. Forgive me. Usually I try to be more tidy in front of the camera. And anyway, if you focus on this is contextual vector. Contextual flow is order of the context. Contextual coverage is how many space you give each of it. So entity attribute pairs actually come in this part. And lastly, when I launch the Semantic SEO course, probably there will be a second course that will be coming after that, and it will be for authors and the copywriters especially. Because even if you are able to create best topical map and the best semantic content network design, with the best possible content briefs, if the author doesn't know how to write, it will be really hard to move from that point. So one for SEOs, one for authors or writers or expert people, it will be given. And you will see that actually mainly we organize and structure our mindset. That's why when I actually talk about Bill Slavsky, I told that he had really strong, disciplined and constructed mindset. His mind was working in a really straight way, in a focused way, without inconsistencies or without conflicts in our thought and also in our verse, linguistically. So let's start here. As I say, there is a case study here that explains my training as well. So there, let me just show you the images first. Dear Dean is here and dear Kevin is here. And Dean from Detroit, as much as I can remember, and we will see each other in Vietnam one more time. And I really love people that actually become my friends after the work. That's why I love SEO. Whenever we are doing something here, actually we get more, let's say, a friendly environment. That's why I love sharing the information. That's why I also tell that in the future I want to share your own case studies rather than mine, because I already published maybe 16, 17, despite I told that I will stop at 10. So probably these things will be the last ones as your pre-training for the course. But after that, I would like to publish yours. So when it comes to the here, they have came from United States to my home and my house. These are my old monitors and old camera as well. And you can realize that even the curtains, I guess this is curtain in English, but you are not able to see it. It is in small cropped version of my camera view. And these are just good memories for me. And I will be publishing these things in the future with maybe more personal details. Because I have promised the dean that I won't be able to give you the industry that much, but I will explain you what kinds of a logic I have used. So basically, these are the screenshots that come from dean. We have started our training in here, and then with the increased speed, the website actually started to take way much more traffic. And this is the Google Search Console view for the same website as well. This is Ahrefs. And this is the Google Analytics. And you can realize actually how in an increased speed it was ranking higher. At the same time, this is of course a spatial day. That's why the rankings are a little drop there. But still, I will suggest you to examine some of these similarities. If you're a good SEO, it means that you are able to read the mind of millions of people that create a kinds of pattern fluctuations that we call actually algorithms. So basically the structure here and the structure in this part and the structure in some of these middle sections as well, they are pretty nearly the same. If the scale will be different, you will see the same structures in these different specific areas too. This is actually how the search engine increases the trust and the prioritization of the source. You can read or watch these search engine trust and historical data and entity-based SEO section. So in this video, actually, I can tell we do attribute-based SEO this time rather than the entity. That's why you can use these and this video also from a different complying angle as well. So let me explain you first what the entity attribute value, data structure, and why it is helpful and how we are able to use it basically. First of all, I have written this case study actually very much before, like maybe 9 months ago, but I couldn't publish it due to certain reasons, maybe migraines, maybe some other things. If you follow me for a long time, you know it. And with that said, here for the Dean's project, once they come to me for training, we realized a few things. First of all, it is too hard to get it in a few days. So that's why I had to create a kind of simple or a pattern there. So that's why actually here I also tell that in my many case studies, I tell that the query templates, the document templates, and the search behavior templates, you connect these three things to each other with a certain type of website structure. Once the search engine is able to recognize a template in your website, they will be able to actually evaluate and rank your website in a really faster and higher way. So here too, once Dean and Kevin came to me, I have trained them and we had some recordings, etc. because one time watching won't be good enough. If you follow me, probably you are watching all these pre-training videos many times, and whenever you listen to them, you get something new. It happens with also my teammates, because they also tell that even if they don't work 1 month, the brain reflexes they have, it's like going and they start relearning again, because in semantics, it's not like technical SEO, it requires learning how to think. Once you get it in a proper way, it will be very much easier, because humans or human mind, we work with reduction, which means that we use less words than we actually think, and at the same time we assume that the opposition will be getting us, or we are not that much good at creating consistent declarations or classes or instances. So that's why I have created a semantic content network design for this project. Then I also have created a brief template. Then it wasn't good enough. I also have written an article template. Then I told my dear trainees here that for the other entities and all of their attributes, use these sentence structures, use these connections, this contextual coverage, flow, and also vector. Then use this type of contextual bridges. If you watch the previous, not exactly previous, because this one here, this video, if you watch it, you will get the concepts of source context, brand identity, and contextual bridge, which are explain actually the main focus, primary focus of the website. In this area, we try to actually structure a document, even if it is semi-structured in the form of text, meaning of the content will be really structured and consistent. So when I create this brief template and article template, they continue to implement it, and the website started to gain way much more, let's say, further rankings without even any kinds of link or branding or these type of things, because it is not needed. At the same time, here I have defined these things let's say with the concept of algorithmic authorship. So let me explain what an algorithmic authorship is. Basically, in this case, I define you in a way of connecting these things with certain types of rules. I can tell you that, for instance, remove this specific attribute while talking about this specific context. If I open my actual Substat profile, you will see that there is a specific article that I have written here, and it is about not author understanding. It is about this, how to retrieve Google search results into a data frame using Python. Here actually I talk about Abraham Lincoln, and I have taken all of the results for Abraham Lincoln with the question of who is Abraham Lincoln. Then I realized something there. Whenever people talk about Abraham Lincoln's assassination, they don't rank for the life of the Abraham Lincoln. Because when you use the concept of assassination, it is too strong word. This is called term weight calculation. If the weight of the term is too much, context will be going somewhere else. This is biography of Abraham Lincoln, but this assassination, it is about how he dies. But we talk about opposite context, how he lived. So that's why whenever they use actual assassination section or assassination attribute there, even I am afraid of using this word too much in this video. We also have an algorithm here, but anyway, when we use these X word or X attribute, we realize that they don't rank that much. Then we start to understand what kinds of a context vector appears there and what other vectors also appear there too. Then we start to focus on word sequences and term vectors, which are future topics. Especially when published the second course for algorithmic authorship, especially for authors and writers, it will be very much easier to understand these things. And then we start to also see all the possible entities that rank for Abraham Lincoln, and usually we see different attributes. I published these articles very much before. You can take these code structures here. I can tell that this is pretty unique research, and that's why usually I am not that much afraid of sharing all the information, even if 10,000 times this article here has been read. And yes, I have written this for the memory of Hamlet Batista. Anyway, and even if I publish these things 10,000 times, you will realize that only the people that are willing to learn, only the people that are willing to put hard work into these things, they will be able to improve their skills. I have published many things until now, and none of the case studies that I put there, they didn't get any kinds of harm. Not because I want them to get harm, but I just mean that do not get afraid even if you share everything, because if you're able to be a consistent player in this game, you will be having all the possible advantages. So you can check this article to understand what I mean there. When it comes to algorithmic authorship, I will be putting all the writing rules, methods, sentence structures, paragraph structures, bridge words, discourse integration configuration, which is another topic. It is about how which sentence should be following which sentence, connections between different questions, which is about inquisitive semantics, and their subordinate tags. The goal of the algorithmic, or subordinate tags, means that after a question, the next paragraph is subordinate of that question, basically. The goal of the algorithmic authorship is to provide strict writing style for certain stylometry, speed up the production of the content without lowering its quality, and increase the value of the content. So this section is important because concept of stylometry. Right now, everyone talks about one specific thing here, which is about generative models are unsupervised predictors of the page quality. So imagine that the search engine looks a section, and Donald Masler here, he is really important. They published a research paper. They have used GPT-2 and GPT-2 types of detectors to understand which pages actually use AI content. And if they are using AI content, they try to understand whether it is low quality or not. So how do they define the quality here? Let me just check this part. Let me read here. Qualitative analysis. Here they tell that attempts at search engine optimization. I don't have that much time. I will be quick. Please check these documents, okay? I mean it, because if you don't check it, things will be half. So I am reading this part, but you will need to read further. So documents that attempt to perform SEO tend to be flagged as very low quality. So this is a prejudice, or this is a stereotype from the Google engineers, because they assume that whenever they actually try to optimize a page for SEO, it is low quality. This is not true. This is true for traditional SEO, but not true for when it comes to the holistic SEO, because in holistic SEO, we optimize UX and also technicalities or technical SEO part, or branding, and also the content in a proper way. And as you know, in my case studies, I don't use fluff, and I use even zero search volume queries, or I use proper sentences. And I also tell you that focus on information density, richness, and accuracy and quality, which I conceptualized all these things in the context of information responsiveness, which will be the name of my next book. So that's why here I can tell that the Google engineers here, they are wrong for the next generation SEOs at least. My point here is that simply string a series of keywords together and therefore incoherent. In my SlideShare account, actually, when it comes to the multi-stage query processing, or when it comes to semantic search engines and query parsing presentation, I will suggest you to check. In one of the inventions, actually, early inventions in the multi-stage query processing, they created a new concept, which is called actual discordancy score. If they realize that some of the highly proximate words, if they are discordant to each other, they assume that the page is spam. And later, this is actually conceptualized with the concept of gibberish score. Basically, if you just put a query or an entity or an attribute there, just putting there, it won't work. Okay, that's why my point there is entity stuffing is not different than keyword stuffing. Putting an entity there, it won't solve your problems. Putting a random attribute there, it won't solve your issues. You have to order it in a proper way, which requires you to learn how to think in a proper way. Even if you're an adult, you might not know it. Unfortunately, it is true. If you just read a simple philosophical book, actually, that's why in the interview of Matt Digid, I told that people that know lawyership, or people that are attorneys and people that read philosophy or psychology or sociology. These people write really good content because they know how to think, they know how to conceptualize, they have abstract thinking skills. But when it comes to the editorial generic skill people, they think in a reflexive way, and you can realize how distracted the focus of their mind. So that's why I stay on these contexts a lot. Basically, these research here, they try to understand actually the content length analysis, topical analysis, temporal analysis type of things by using OpenAI detector. And they try to actually understand how the quality of the documents actually change. So we have talk about these things because we try to actually understand the concept of stylometry. Stylometry means that I have explained it actually in my Google author rank research. If you just check this article, how Google knows which author is real authority. Here I actually explain what stylometry is. In the American Constitution, there was a lost section, not lost, but imagine that there is a constitution that belongs to the United States of America, but a section is there, but no one knows who has written it. There are two possibilities. One is Alexander Hamilton, and I really a fan of him. You can even read the production reports from Alexander Hamilton. It will solve actually many economical crises today. But anyway, actually this is what we call as basically, let's say we can tell that this is actually delusion of the contextual vector, because we have talked about an entity, Alexander Hamilton, then that attribute came there because of the inquisitive semantics in my mind, and it was about his book. The book was about a specific topic, then we start to talk about that topic. So basically, information retrieval became a second context or micro context in that paragraph, which is a problem there, but it might help for entity resolution. Anyway, when it comes to stylometry, basically we try to understand whether the document has been written by the same author, a different author, or what kinds of a style has been used there. Because when you write the text, basically it is so easy to personalize your expressions with you. I call it expression identity. Basically, author identity and expression identity have to be actually, let's say, aligned. If you use certain types of word sequences, and these certain types of word sequences also appear in other 500,000 websites, it means that you are not authority or you are using AI. This is also called statistical signature. The statistical signature means that since certain types of words will be used in these word clouds, very well, in these word clouds, for instance, for certain types of topics, you will realize that certain types of websites use certain types of words. So basically, they understand that, okay, this is coming from this AI because we use this AI system and we are able to understand these statistical signatures, which is the same thing nearly with the stylometry. So basically, when you use algorithmic authorship, you are able to actually create unique text faster than AI, more quality than AI, more accurate, and it will be completely, let's say, unique and also original style. Basically, it won't be similar to the AI. I will be showing you how to do that in a proper way. Once you get it, you will understand why actually microsemantics is so important. You will get how a single comma, how a single attribute, how a single further entity or contextual, let's say, step or kinds of, let's say, an extra question can change the rankings even further. If you check my actually, let's say 2023 SEO trends or deep insights thread that I have put into my Twitter account, you can actually get it in a better way. Because microsemantics is about small changes in the content, how they can create big differences. And you will also understand that how a single sentence can increase the quality of that paragraph, and how that improved paragraph can increase the quality of the next paragraph. And if we unite these and consolidate this increased quality further, how can actually it make that specific web page rank higher, and how actually it can make the connected other web page rank higher. So that's why actually site quality is not about just a certain section of the website, it's about every section, every text, every content item. That's why in holistic SEO tutorial that I have published in this channel, I told you that optimize every pixel, every byte, and every letter. Nothing is random in SEO. We should be optimizing everything. Here, if you watch this video, you will get it, and this is the most practical video that I have ever published, and that's why people actually like that a lot. Okay, so we defined the algorithmic authorship. You can check the Google author rank as well. But what is algorithmic authorship template? basically we create a certain types of algorithmic authorship design. Then we actually create this content item brief. Involves all the context vectors, structure, hierarchy, and connection for covering a topic based on semantic SEO. Then imagine that we give you all of the actually, let's say, possible sentences, tables, table columns, or rows, lists, list item count, or what will be the first word inside the list items, paragraphs, or even, let's say, table head and table footer, or the sentence before table, after the table, etc. Once we handle all these things, you will realize that we created a template according to that topic. Then you will need to implement it in a proper way. And I will be showing you how to create these best possible templates and how to use them. One more thing here. Listen here carefully. Please do not use templatic approach unless you don't have to, because even if that template is really good for this amount of queries and entities, it won't be good for the next section that much. Eventually the context will be shifted. Eventually the context vector that you have created won't be aligned with this specific entity attribute pair there. So that's why templates should be used if you have to use it. I usually use these things with the small teams if it is urgent. And as I said, in Kevin's and Dean's situation, it was urgent. They have had like 6 days with me. So it wasn't good enough time. So that's why we have to use this system. Then other beta testers came to the Istanbul. I trained them. The same situation happened them with them as well. That's why I do not think that watching the course only one time will be giving you everything. You will need to watch it repeatedly. You will need to repeat these things for different topics in a different way. Then it will be a reflex for you. You will start to feel, because as I say in the topical map SEO case study that I have published here for the expansion, we are able to actually create different algorithmic authorship templates and different content or semantic content network designs so that one of the websites shall rank higher than other. Imagine that you're able to design a contextual flow and also sentence structures in a way that you can tell that these will rank 20% better than this one. You are able to even determine it. So that's why I'm telling that this is like the end game of SEO. If you are able to determine all these things, like it's like telling that if we remove these headings and if we add these tables, you can tell that with 20% this will rank lower. If you're able to do that by thinking, then you can actually start to optimize everything in a better way. This example here is actually have that. We have 2 websites here. You can realize that these 2 websites have nearly have the same graphic from the same algorithmic updates. They get the same graphics nearly. And then you will realize that one of them ranks higher than the other one most of the time because we configured that in that way. So that's why this is called semantic content networks, and that's why I will suggest you to actually understand the theories here, because you will do it only once, then everything will actually be, let's say, pretty easy once you get that level. The next level here is using AI. If you're able to use AI in a way that you can trick the search engine with all these rules and other things, then you can print websites as much as you want. But still, eventually, they will get you by using these, let's say, detectors. Even if they're not able to detect your text, they will detect your publication frequency. Or let's say they will check your Google Search Console account or your themes or other things. They will locate eventually and they will start to use it. And that's why in my 2023 Deep SEO Insights, I told you that they will do also mistakes. Even if you don't do something tricky, even if you use just real humans, if they don't believe that it is coming from real humans, again, they can demote it. It is already happening. We already experienced these type of things while fighting against these engineers, even if I like the inventors. So these will be published. It will be there. The video is ready, but I didn't put it there yet. And here we have a question. Can 2 different algorithmic authorship templates be configured rank accordingly? Yes. If you read these parts, you can get further details. So what is content configuration? Let me explain that, because you will see these things even maybe in the second lecture, you will see these things. So basically content configuration is that, let's say you have realized that in this example, when you put actually a certain types of attribute, to the early section of the content, it doesn't rank that much. If you are able to recognize that, you will need to go back and you will need to configure this. What if it happens also for other entities that you process too? Maybe certain types of attributes decrease your rankings for certain types of context. Then you will need to go back, you will need to continue to configure it further. And sometimes, this section is important, we always assume that knowledge graphs and knowledge bases or knowledge vault of Google, it is structured based on entities. What if it is structured based on attributes and they just distribute the entities around the attributes? This is what about actually EAV. Basically, we put attribute to the center, because if you have an attribute context in a heavy way, like assassination or like presidents, these are attributes actually, and also occupation. President is occupation, assassination is unlucky situation, you mostly. And if you get these things in that way, you will realize that if attribute is heavier than the entities itself, especially in the query semantics, if you watch this one here, you will get it. As I say, everything here that I do, it completes a part. If you are able to do that, then you will realize this. Basically, some of the specific attributes should go somewhere else, and some of them should come earlier on certain types of information retrieval zones. Information retrieval or IRL zones means you are putting certain things to the certain sections so that they can increase their weight in terms of contextuality. So if you continue here, we will finish this article, then I will explain these things. It will be very much better. We have spent half hour here. Probably in half hour we will finish these things, don't worry. So what is entity attribute value architecture? Basically here we have a city. Let's say this is an example of it. A city, population X. A city here is entity, population is attribute, X is the value. Entity attribute value. So a space, efficient knowledge representation model. It organizes data into an entity, specific attribute and value that changes. It helps to cluster and store similar entity attributes together for a better understanding and serving of the query owner. So the entity attribute value model can be enriched with extra dimensions like dates, ranges, specific demographics, reasons for the population amount, or even a change in percentage for the last year. The entity attribute and value model is used in hospitals, courts, justice systems, educational systems, machine learning, and any kinds of database, including search engine systems. Because in 70s, 80s, and 90s, the system have been used actually in government buildings, then it started to be used inside information retrieval. The presentation of semantic search engines and query processing, if you check this, it is what I mean here, I will link it, explains the browsable fact repository from Andrew Hook, which is a Googler, or who is a Googler, the name behind the Google Knowledge Vault basically. It explains how a search engine can generate and use browsable fact repository for anything that exists. Later, Andrew Hook's inventions led us to knowledge graph and base of Google in 2012. So I have also defined these things here, but this section is important. Please listen carefully, because in attributes, you know what an entity is already, I hope. I will skip it, but when it comes to the attribute, there are different types. Composite and simple attributes are two different types of attributes. Composite attributes can be parsed as two different types. For example, composite attribute can be size. Size can have height with depth. Simple attributes are the parts of the composite attributes, such as height. It can't be parsed or chunked further. It is a simple defined attribute. But an entity can have multiple same or simple attributes. For example, height can be attribute to two different other types of same entities, such as hill height or window height. These two can belong to a car at the same time. These are called indirect attributes. A direct attribute belongs to a specific entity, while an indirect attribute belongs to a specific part of the entity. Part of the entity. This is about lexical semantics that I explained with 26 projects in this area. Please check it. Understanding lexical relations and hypernyms or hyponyms are necessary due to this. These are more attribute types, such as single-valued attributes and multi-valued attributes. Single-valued attributes have only a single value, such as age, but multi-valued attributes can have multiple values, such as college degree or known languages. There are also derived attributes and stored attributes. For example, derived attributes can come from another attribute. If something is made of iron, it should be hard. If it has an age, there should be a birth date. These are derived attributes. I hope you see everything is not in the queries, okay? forget these keyword difficulty or keyword matching or these type of things. Focus on the meaning as much as possible. Understand these contexts. I won't read further these areas, but I also have put the most important or relevant Google patterns to here. You can also check it. This is about Subjective Attribute Manager, a system and method for identifying and predicting subjective attributes for entities. Media clips, movies, television shows, images, paper articles, blog entries, persons, organizations, commercial businesses are disclosed. In other words, in one aspect, subjective attributes for a first media item are identified based on reaction to the first media item, and relevance scores for subjective attributes with respect to the first media item are determined. So let me explain basically in layman terms. Let's say you have written an article and you are an authoritative person. Let's say you're told that Brooklyn is a city. It's not. Brooklyn is not a city. But let's say you have said it, and it is your subjective opinion. And if there are a few more sources that use the same phrasification for Brooklyn, it will be perceived as a city. City will be the type of that entity, and Brooklyn will be the instance of it. And at the same time, it will be having the attribute city. It will start to change its meaning under certain conditions a little bit. It is subjective. Let's say you say that this motorbike is too fast. For me, it's not. So in this case, if there are enough level of sources, they will accept it as a subjective attribute. This is also about product review update, to be honest. If you check this specific presentation from me, how search engines leverage opinion-based articles for ranking. Whenever I create these things, I create them like ebooks. If you read all these things, you will get actually what effectoid. Effectoid is unification of an opinion with effect. Basically, we are at the age of the factoids right now, and this is why actually ChatGPT won't be able to replace Google, because ChatGPT-like systems, they have to give you a direct answer. If I tell you what are the components of car insurance, ChatGPT will be telling you that's 6, but it's actually 10. But in another source, it's 9. So in another state, it is 15. In another country or continent, it's just 2. So that's why actually using multi-choice answers as web search engines today, it's better. But still, you can have some representative answers for your quick needs by giving the sources as well. So do not get scared. SEO won't be that. Probably it will take a really long time for that. It might not even die, to be honest, forever, because the search will always be something real, and there will always multiple sources. All these sources will be competing against each other, and always there will be a need for curator, and this curator will be the search engine most of the time. As long as we need for searching, something will need to be indexing all these things and ranking these things. So it's like coming from our nature, so it won't go away. So I explained content configuration already, and this one here, check this name, Dimitri Myerzon. I didn't hear the names. I always read the names, so I don't know how to pronounce it. Probably Dimitri is Dimitri. Myerzon, I hope I don't butcher his name. But here, when you look at here, click distance is something important. This is about website 3, and it is about subsite retrieval and topic distillation. I didn't explain these concepts even once until now, and I won't be doing it right now too. It's not our topic. We need to focus on this concept. Maybe in another video to complete these things, I can do that. But basically, imagine that you have chosen a source context. To understand the source context, watch the topical map expansion case study. Then there is a specific type of entity here with certain types of context. The thing here is that this thing here, it will be evaluated according to this thing here. So if this thing doesn't follow a proper contextual flow here, it will have less, let's say, relevance. So it's the point there. And when it comes to the key attributes for entities, how to find the most important attributes or the most, let's say, essential attributes for these things. It is about document statistics and user behaviors. That's why I always tell you that do not go for imitation of the search engine result pages. Go beyond that, because topical authority is forcing other websites to imitate you. If they have to imitate you for being an authority, it means that actually you will have an actual permanent advantage there. And when it comes to the document statistics and let's say certain types of word sequences inside the documents and certain types of website structures here, they will be getting actually the most important attributes. If these attributes also appear inside the queries, they will assume that these are the most important ones, but you can actually affect these things. One more thing is that the key attributes, they are built in, which means there is no way of defining that thing without that attribute. I guess these are enough. In the course, it will be very much more direct with practical explanations, and you will get it directly. So you will tell that, I remember these words before, and this is how it is done for creating the content briefs, etc. So value set for the attributes. The value set represents the specific values or value types that can be assigned to an attribute. For example, for the attribute height, the value has to be type of the length. This is actually also about this area, generating query answers. Directly, if you go to this website, generating query answers here, you will see there are constraints. The constraints like type, temporal, gender, relationship, according to the query phrases or phrasification, there will be certain types of constraints, and that's why again EAV is important as like the subject-predicate-object model. And neural matching has been mentioned here because if I ask you how long, which means that you will need to have a time unit in the answer. If I tell you percentage, you will need to use percentage. If I tell you how much, you will need to use currencies. If they don't exist in an early point, you won't rank. So when it comes to here, you can read these things, by the way. For a query like X degree in Africa, the search engine might determine specific question formats. Question generation will be shared in the book that I am writing with every detail. It is already has been written. Since I have written this case study like 9 months ago, it says I am writing, but the modality here should be different. But here we can tell that for search engines generate some questions such as X degree in Africa for hunting, for cooking, for traveling, for walking, the places in Africa for X, and some other things as well. You will need to connect all these things with certain types of, let's say, index construction methodologies. Examples for entity attribute value models here. We have some examples, and we also explain why JSON is needed, because EAV is where the JSON LD comes from, because JSON, it is easier to compress, easier to process. EAV is better when it comes to actually, let's say, bringing a result from a certain topic, but JSON is very much easier to store, and that's why the search engine actually prefer the JSON as well, or JSON LD, because as I say, really light and really clear to parse and easier to understand. So let's say here there are a few things to understand more, and let me just read here. The EAV model can have substructures. For example, a plane can have wings, wings can have engines, and engines can have different types of subparts. All these parts have different types of attributes, and all these attributes represent different types of value sets. Thus, EAV models can have complex structures and traversal retrievals. Traversal retrievals are for retrieving the data of an entity based on connections from other entities. Imagine that a search engine tries to take information for a specific context term that contains two different entities. In this case, thousands of different queries and tens of different attributes from different contexts are needed. Thus, different types of semantic networks, SERP samples can be used, or even SERPs can represent different knowledge graph designs, and semantic networks can be updated for all other SERP instances. With that said, specific context term entities can be taken and used based on the connected EAV class relationships. An EAV model for the cars and EAV model for the planes can have engines and some other parts mutually, and this connectivity can bring them together for traversal retrievals. In actually topical map expansion, I told you that sometimes instead of connecting entity to the query, you will need to connect entity to the interest area. Then you will need to connect document to the interest area back. There are different ways of information retrieval: connecting query to document, or query to entity, entity to document, or query to entity, entity to question, question to the document. There are multiple ways, and you will need to optimize the document for all of it. When it comes to traversal retrieval, it is about getting a certain attribute and value for an entity by checking other frames and other connections as well, because they will be searched together and they are from same type, or they are coming from same ontology construction. And when it comes to here, in the frames section of the Understanding Words of Life SEO case study, if you watch this, it is already published from before, we have processed the subcategorization of frames. These frames help a search engine categorize situations and connected concepts. Similarly, in EAV models, an entity can be called via mutual attribute from another EAV model. So basically, the previous video focuses on predicates and verbs. Frames or frame semantics, it comes from verbs. And here we focus on the nouns and the adjectives or the parts of these nouns with the lexical relations. That's why you should see this free training or free pre-training as a construction of, let's say, a better methodology for structuring the thought or creating better arguments. And here we have a specific, let's say, patent, which is ranking search results using language types. Let me read it. Search query on a network are ranked according to the additional ranking function for the prior probability of relevance of a document based on document property. The ranking function can be adjusted based on the composition of the language that a document is written and the language that is associated with the search query. Both query-independent values and query-dependent values can be used to rank the document. So let me explain here a little bit, because when we say the language type, we actually don't mean just the tonality there, because every query that we search for, it has a certain types of phrasification, like how do I do hummus, how can I do hummus, how to do hummus, and how I should do hummus, or how many hummus should I do a day, how many hummus should I consume a day, or how many hummus you should do a day, how many hummus an old woman do a day. I can continue for all day, so let's stop here. But basically this is the, let's say, a little bit language type, not just a language name or language, not like English and French. It's about the question format, how do I do, or how do you do, or how to do. So we ask same thing with different language models. And usually when we do these things, we put a different angle to the content and we are trying to match it. It is about, again, the attributes, because the context even there, it will be changing slightly. Attributes of the hummus doesn't change that much, but according to the semantic role labels, in one of the labels you are the agent, in one of the labels someone else is the agent, and in one of them there is no even an agent. So the label, semantic role labels change based on the sentence structures there. That's why the answers also will need to change with that. So let's say this section is important too, because in the patent they actually create different attributes for documents as well, according to the type of the file, or term frequencies, or certain types of other statistics like proximities, etc., or like in this example by using or mentioning the assassination as well. So let's continue. A brief history of the EAV model. Here I explain actually how it came up, and I explain what Lisp is. It is an important thing too. I also mention it actually in this case that I have written before that explains the creating the semantic content network. And then we also talk about the UIMA, which is unstructured information management, basically, and here, or unstructured information architecture, sorry. And in this part, actually, we try to understand how we can construct a certain structured database from unstructured information, and EAV model was the first thing that we were able to configure there. Sorry. And in this one too, I have mentioned this specific pattern before too, because this we will see it in a similar way. But imagine that here we have attribute and value. The link here is actually for your, let's say, the specific page, and there is an object ID and fact ID. So this is important because if I change the value for this attribute, the fact ID will change, but object ID will stay same, which means there are multiple facts or factoids, as I say in this area, factoids or opinion-based facts for the same entity. And once we put all these things into the fact repository, we are able to actually locate all these things. And if you are giving better facts or factual information or more accurate information, you will be able to rank actually higher as well. And here, these are the sections from the specific patent. It says identifying a source document from which one or more facts of the entity represented by the object were derived, identifying a plurality of linking documents that link to the source document through hyperlinks, each hyperlink having an anchor text. And this is about how we use actually contextual bridges between the documents, because usually we use attributes, or usually we use a similar another entity based on the ontology there. So it will be explaining that, and some other things also exist here. You can read it because I will need to be a little quicker. So metadata and logical schema of the EAV. Here we try to explain actually why it is relevant to the resource description framework and how it turned itself into the JSON as well. And here we have a specific, let's say, example one more time. It starts with, let's say, attributes and value facts associated with specific entities may include specific fact types of the values associated with them. For example, for George Washington, we have a date of birth attribute and a value like February 22 and 1732. So the invention name here, learning objects and facts from documents again, which is about document statistics as here. And once we get all these statistics from the specific documents, we try to understand which attribute is key. Then we start to get actually multiple values for these attributes, and we can restore them. Then we can actually start to, let's say, put certain types of accuracy scores or information responsiveness scores for certain types of documents. At the same time, we can get new connections based on these things, and the connection section is explained, especially in this one, a little bit further. So if you read these documents, you can actually see further explanations or more important things when it comes to the, let's say, knowledge domains. I am trying to move faster, but if you read these, they will be useful for you, because we even talk about brand SERP optimization or knowledge panel management, because you will also need to construct your own brand as an entity, and you will need to add your own attributes there in an accurate and relevant way. So metadata types, what kinds of metadata can have an EAV data sample? For instance, validation metadata limits the possible values for the attributes by auditing the ranges. This is about truth ranges, which is a concept that I found. Basically, if I ask you what is the best temperature for hunting in Africa, which question is ambiguous, and Africa is a big continent and geography, which part of it, in Sahara or in savans, basically. But usually, based on document statistics, we will get the context of savans or savanna. I don't know how to pronounce it, basically. And once we get there, we will need to give a kinds of validation metadata. I can tell you there 60 centigrade is the best temperature there. I will need to assign many other ontologic attributes for this context, like best temperature for human mind, best temperature for exercising, because you will, I don't want to tell it, but hunting can be seen as an exercise based on the semantic connections, because in many documents it is called as sport. So that's why it's not about what I think, by the way. To be able to rank there, you might need to mention these things, unfortunately. And when it comes to this section here, corroboration of web answers, a few times I have shown these things also, but maybe it might require a new video there as well, or even a new book, to be honest. Presentation metadata helps to explain how the metadata of the specific attribute of the entity should be presented on the UI. This section is relevant to the information retrieval and also information foraging. That's why we mentioned many times for search engine result page UI construction inventions, especially in the previous case study here, because if you're able to understand how they actually construct the UI, and also in Google Keys we see it a little, if we are able to understand how they actually construct the that specific UI, then you can actually understand what kinds of attributes you should be focusing on further. The important thing here is that these attributes inside the presentation metadata, they are also coming from document statistics. It is not a rule or fundamental thing there. You can change it. Grouping metadata, attribute types and relations are represented with the groups of the metadata. The size related attributes and taste related attributes are grouped differently and connected to different queries and the contexts. For instance, if something has a size and also a kinds of, let's say, taste, the other derived or connected contexts and the attributes will be grouped together. Dependency metadata. The dependency metadata determines the ranges of the truths based on the other attributes. For example, maximum speed of a land animal can change according to the average speed and gender attributes values. Thus, maximum speed attribute is dependent on other two attributes. Without explaining them, you can answer the other one. Complex computation validation metadata. So this is a little bit important. The complex computation validation metadata turns the existing attribute values into different representations, such as percentages or proportions. Thus, a specific metadata content of an attribute has to be evaluated over the 100. Since the percentages have to be completed to 100, this helps information creator to make the textual and visual representations richer and more unique with different expressions of the same value, such as from meters to feet, euro to USD. In this section, I actually explain why the JSON has been used and why it should be used. because JSON and XML are different types of structured data for representing the information in a relational database. However, due to some fundamental differences, none of them are strong enough to be compared to EAV. EAV databases are able to store, retrieve, and present complex entities with more details, while JSON and XML are limited to the specific instance of themselves. For example, the EAV with classes and relationships involves complex sub-instances that open a new attribute tree for the existing superior entity, while these attributes are inherited and transferred with a logical tree. This transfer word, please remember it, we will see it. Transfiguration of Google Knowledge Base. We will see it. JSON has another benefit compared to EAV, which is speed. The EAV is hard to process and store, while JSON is way faster to retrieve, construct, or modify. Thus, EAV and JSON are united with Open Schema by helping EAV databases to involve JSON structures in the rows. These bring us to the concept of row modeling. So row modeling is actually something easy. Imagine that in your data structure, you just create a row. Inside the row, you put anything there, like technique, let's say, yes, I can tell row modeling is a semi-automated way of structuring entities as humans do, but it has some limitations. And row modeling is associated with a single angle and entity for specific context. In other words, multiple rows and models are needed to structure data for a specific entity. When you use EAV, when you add an attribute, that attribute is connected to another attribute, and that attribute is connected to another entity. But when it comes to row modeling, every row is independent in that data structure. That's why you can assume that EAV is unification of all the rows for that specific entity. That's why it is actually more flexible, multi-layered, and that's why it has more context. The only thing there is, it is slower. That's why using EAV and also a JSON type of structure is a little bit more important. When I show you actually these UI or presentation metadata and a little bit of Google keys one day, I hope, it will be even more, let's say, certain at least. So this is also bring us to the, again, one more time to do some of the research papers, like using query patterns to learn the duration of the events. So as I say, the query patterns, they're always important, and inside the query patterns, many information can have a place there, and we can try to predict certain types of attributes based on other attributes here too. And if I read some examples here, we learned that war lasts years or decades, while look lasts seconds or minutes. Learning aspectual information is an important goal for computational semantics, and duration information may help and enable rich document understanding. We first describe and improve supervised baseline that relies on event duration annotations. We then show how web queries for linguistic patterns can help learn the duration of events without labeled data, producing fine-grained duration judgment that suppress the supervised system. We evaluate on the time bank, duration corpus, and also investigate how events, participants, or arguments affect its duration using a corpus collected through Amazon Mechanical Turk. We make available a new database, etc. And here we some examples. If the event actually lasts between 5 minutes and 1 hour, we can tell that a Brooklyn woman who was watching her clothes dry in a, let's say, laundromat. 1 week to 3 months, Eileen Collins will be named commander of the space shuttle mission. 3 days to 2 months, President Clinton says he is committed to possible strike against Iraq. So basically, these things here are important actually again for semantic role labels and also updating the knowledge base. Basically, according to the attribute that has been assigned to the specific named entity, the specific attributes validation can be done. If you see that actually a Brooklyn woman watch something goes dry, basically you can understand that that attribute lasts for this amount. If we talk about Ellen Collins and space shuttle commander, let's say, we can tell that this title or this attribute will be valid for between 1 week and 3 months. So these duration prediction tasks, as it is said, it is important for rich document understanding. Even if it is not written, even if it is not searched, still search engine will be using natural language inference to extract these further information, and then they will be putting these things into the other sections inside the EAV for certain types of attributes as well. So this part explains why you, let's say, unstructured information architecture is relevant to the EAV. And then I won't read this part, but basically you can see how the ontology has been constructed based on the queries. Here too we have many queries. Then we actually get attributes from these queries. Then we start to actually create an ontology and based on just the query networks. And the query networks or the query streams, they're also coming or consistent with web documents one more time. So it also helps us to increase the confidence score even a little further. And here we have another research paper that tells what you seek is what you get. Extraction of class attributes from query logs. One more time we check the query logs. And here basically they tell that the method extracts attributes such as capital city and president for the class country or cost, manufacturer and side effects for the class drug without relying on expensive language resources or complex processing tools. I hope you get it, why they have to check the queries, because when you start to answer 6 billion queries, let's say, you have to find easy ways. This is also why actually the ChatGPT-like systems can't replace Google, because Google always does these things with, let's say, less cost in a eco-friendly way. And here, without using or processing all the text in your documents, and many times I told you that without you prove your overall quality for your website in a unique way, Google won't be processing the text on your web pages. And that's why even sometimes the gibberish content in really authoritative website continues to rank, because Google doesn't check their content every time. But once they process their document in a proper way, with a broad core algorithm update, they start to lose rankings. And here too, without using expensive language resources or complex processing tools, by just checking the queries, we are able to actually get classes of entities based on just certain types of attributes, and we are able to create an EAV model just based on that. And then we can even go further, and for certain types of attributes, we can understand how long they are actually valid there. So we can extract further information all the time, and we can actually get more, let's say, important things there. I also define the attributes types here, like root, rare, unique, and these are important for actually, let's say, semantic networks and semantic network creations, but I won't read that part for now. And here, if you look at the definitions of those attributes are expanding in semantic SEO course, as I say, and I have some simple example from the Google. Basically here, if you check these attributes, let's say these are the top 10 attributes acquired from the query logs. For countries, it is capital, population, president, map, capital city, currency, climate, flag, culture, leader, drug side, effects, cost, structure, benefits, mechanism of action, overdose, long-term use, price, synthesis, pharmacology. For companies, CEO, future president, competitors, mission statement, owner, website, organizational structure, logo, market share. For city, population, map, mayor, climate, location, geography, base, culture, capital, latitude. For painter, it becomes something else. And based on this, we are able to actually rank these attributes according to their prominence or repetitiveness one more time. And once we check these, the precision or the heaviness of these attributes, for which type of entity, which type of attribute actually weights heavier, we are able to take them as well. We also get their instances. Even if you create a template, article template for certain class, you will realize that for certain specific entities, it won't be that much heavy. The heaviness of these things will change according to the root, rare, unique attributes. And these are actually my concepts one more time. Attribute and EAV connections. Here we give further explanations actually for certain types of query logs, and raw candidate attributes are coming from query logs. Then we generate questions, then we get these undefined class attributes, and not every class has to appear inside the queries one more time. And these are the last words. Here actually I explain Google Base, why Google Base is important and what Biperpedia is. As I say, in half hour we are nearly finished. Biperpedia is like knowledge base, but imagine that Google actually constructed an kinds of knowledge base or knowledge vault just for the attributes. They know which entities exist in the world already, but they don't know what aspects, dimensions exist for these entities. That's why I tell you to focus on the attributes actually. And Biperpedia here, it explains basically what kinds of attributes exist, and Google knowledge base connected there is because Google Base is connected there because Google Base was really similar thing to the question hub. In question hub, you submit a question, but here in Google Base, you submit an attribute. Then Google Base actually became Google Fraggles, and Google Fraggles became Google Merchant Center, because many people actually submit many products here, and this is why actually product lines are important. If you watch the SaaS SEO case study, you will get actually what I mean in this part as well, with many explanations, and it also explains why the specific, let's say again, the query semantics a little bit, but also especially the product line is important. Sorry for showing the email as well. Anyway, yes, usually I have 83 for now emails. So now we have finished this part. If you read this section, you will get the importance of attributes for them. Without the attribute, again, one more time I'm telling, if you don't have the attribute, you will have subject, you will have predicate, but object won't be there. If you don't have the attribute, you will get entity, but you won't get the value. Attribute is more important. Understand it. So now let me explain some of these sections quickly, then we can continue to our lives. So this one here, actually, this specific research paper here, it is about identifying entity attributes, again from Google, and Rahul Gupta here, he is important. And when it comes to the here, I have already shown this thing inside my article, but if you check further explanations here, you can get certain types of entity attribute value structures directly from Google's own inventions. And here you can also see how they are actually phrasificate these things with what kinds of connections. And if you read these parts, it will be really important. And more distinct attribute names, for instance, they can also find what kinds of ontology can be constructed there. It is important to understand. In identifying or inferring attributes from search queries, as I said, duration of events can be inferred based on the words like looking, war, signing, being assigned as a commander to a specific place, etc. And here inferring attributes is also about natural language inferring, and here they are actually trying to extract more and more attributes, like receive the description of the search queries. Description of the search query is something that actually I explained for query processing. We have query aspect, query context, and also query definition basically, and these three things follow each other. The query aspect is like the theme of the query. Like when I search for the Hawaii, basically it is about mostly Hawaii hotels. And if you need the context there, you will need to phrasificate a little bit further, and the definition of the query actually gives us the purpose or the need behind the query. And infer instance attributes from the description of the search queries, assign instance attributes to categories, refine instance attributes, associate refined instance attributes with categories. If we have certain types of categorical queries inside our website, we will increase the categorical quality of the website, which is coming from Trees and Upstill. I also have shown it before. And you can read these query templates. What is the E of A? The A, blah, blah, blah. And we have, again, friends, capital, population, company, CEO, revenue, market, website. This is a different patent or invention. As you see, they are all overlapping with each other with consistency. Once it happens, you get that you are looking at the right part of Google. Identifying entities using search results. So we have inferring attributes from search queries. Now we are looking at the results. But imagine that inside the search results, we can look at the SERP, or we can look at the individual documents. Receive search query, process search query conventionally. Names of medical conditions should be returned. We have ask a question, then generate combined queries, obtain search results for each combined query, generate a summary score for each medical condition. So there is something important, but sorry for saying that, but most probably 70% won't get it. In the previous video, in the topical map expansion one here, this one here, I have mentioned that there is something that actually we call as composite search score, or composite score for categorical results. There I told you that actually rather than scoring individual documents, they collect group of documents and they score them as whole. And this is about that a little, because basically combined queries and composite documents, basically when you unite 6 documents to rank together, they should be covering all these combined queries. If they don't, it means that the search engine result page won't be answering every possible query, and that's why getting all these possible connections is important. And if you get the situation like this, not every document there is your competitor. Some of them actually will be helping you to rank higher. That's why, according to that, you need to create a content brief in a way that you complete the missing parts, so that actually the composite score, thanks to you, can be higher for certain types of combined queries and the attributes that we can take from these parts. And if we get these parts, you can just check this specific sections here, like entity identification system, indexing engine, etc. This indexing engine and ranking engine, these appear a lot inside the patterns, and probably it is a kind of section in their system. I can tell it repeats all the time. So when it comes to this one here, providing search results based on compositional query. See? Yeah, let me go to the top. So identifying entities using search results, and we have the combined query here as a term. Then we have a new invention here that actually directly focuses on that. And look at the inventors here. Some of them might be overlapping, and if you check it, you can see sometimes actually common names between these, or different teams also might work for these type of things as well. So from time to time, at least, let's say, it might happen. But this part here, we have Shanghai, so which means a different Google team most probably does that. Provided search results based on compositional query, and here we have many things, like many explanations basically. And here, once we process the web pages or data structure and the queries and all the resultant entities, and then we try to actually get a proper, let's say, collection of these things. We have IDs, types, and these IDs represents the objects. Then we have different types, and we get all the compositional queries. Then we start to check which type of ID from which class actually, let's say, is covered there. Then we are able to actually give these things in a better way, or rank these things in a better way as well. So every invention completes each other. This one, extracting facts from documents, and it is one of the important inventions there as well. So in this case, actually, to be able to extract certain types of facts, you will need something like this. From search engine point of view, the subject in the triple identifies an entity, the attribute in the triple identifies an attribute possessed by the entity, and the object identifies a value of the attribute for the entity, basically entity attribute value structure. Example entities include people, places, countries, landmarks, animals, historical events, organizations, business, sports teams, sporting events, movies, songs, albums, games, works of art, fictional characters, and so on. They have to give this much detail because this is a legal paper. If you forget one of these, it might create a legal problem in the future. That's why I write these things. They mention Freebase here. This is something that I already actually bought it. If you see that one of the entities start with the M, or one of the entity identifiers, if they start with the M, it means that it is actually coming from the Freebase. And here we have many other entity or attribute examples, to be honest. For instance, when you ask a query like, who is the chief economist of example organization, may be classified by the search engine as seeking to determine the value of the chief economist attribute for an entity example organization by accessing the fact repository. The search engine may identify the fact repository include example organization, chief economist, example economist. See? Let me just show it like this. If I come to the top of this document, it should be somewhere here. X city, city, population X. The same structure also appears directly in this area as well. Then here they will try to actually get corroboration of the answers, or what kinds of sentence structures should be used, because these things are not that easy to get directly from these parts. And if you just check the claims, basically they will be giving you overall summary of these things. Generating a plurality of the patterns from the seed facts, wherein each of the plurality of the patterns is dependency patterns generated from dependency parse. So dependency, it is already mentioned here too. So there are two ways. You will get inventions, or you will get these things overall, because every invention, they already touch these things, or touch the EAV model basically. And this one here is about object level ranking, bringing order to web objects. This is actually a research from mainly the Microsoft. But here actually, again, we try to store all the attributes, then we try to connect these things according to that, like conferential journal, a paper object relationship graph, they say, paper and the author will be there. And this is the web environment example. And here we use certain types of web, let's say the backlinks, and according to Microsoft, these entities, they are called web objects. And in every web object from different types of web pages or web databases like datacommons.org in an integrated way, we will be getting different facts and different objects, and we try to give them a kinds of order. By the way, Microsoft's knowledge base, it is called Satoshi, maybe? Is that Satori? I guess it was something like that. It is called understanding, I believe. Yeah, comprehension. And a Japanese Microsoft engineer, as much as I can remember, I don't remember the name, but he created the Microsoft or Bing knowledge base, and he called it Satori, which means understanding, search engine, as Andrew Hook already stated, because he called semantic search engines first as understanding search engines. And this is the algorithm that they created, which is a good example. It doesn't have to be that much complicated. You don't need to focus on the code. This is code 2, by the way, but this is pseudocode. Pseudocode means that we give first verbal communication or verbal understanding of these things. Then we have these other explanations. Then there is a case study here to get the relationships or facts or what kinds of evaluation can be done. It is just 8 pages. If you read it, you wouldn't lose something. Sometimes I print these things, by the way. It will be easier for you to actually read it, because reading from screen, I believe it is not that much good, because for instance, since 2019 I use the same BERT research paper and I have my pencil marks on that, so it makes easier for me to recognize the previous sections. So let me read this part. Clustering all objects with a known entity type, which means class type and or class name, and object here means instance. Build a cluster prototype for each cluster, refine cluster prototypes using object of unknown entity type, calculate similarity values between cluster prototype and object of the entity type. This is about Wikipedia. They are trying to get actual new attributes based on the similarities between these things. If it is too similar, it means that actually it is from that instance or that class, or it is from a different class basically. And you can check this entity type assignment, and this explains how it can be done. Entity type module, entity type assignment module, and this is useful also, as I shown before too. It is useful for knowledge panel management. And before I told you that when I searched for Elon Musk, I have seen that he was mentioned as directly the CEO of Twitter, but it is actually his last title, not the biggest, not the most important. But if you check the document statistics, he has been mentioned as the CEO of Twitter more than CEO of Tesla. So that's why the title according to the search engine has changed, which means the key attribute has changed too. This is about document statistics at the same time, and you don't have to align with that. Search engine will find a way to actually classify or refine these things further and further. This is also not that long. By the way, in patents, as I say before too, they also give things about serving these things, and if you read these details, you will realize that they go with the same examples. Kingdom of Spain, I have seen this many times. George Washington, here, same, and date of birth. How many times we have seen it? It's not different, only their explanations and methodologies and construction of methods a little change. So that's why it will be better for you to check these things as well. This one here about generating ranked list of entities. So this is about, basically, this is the patent of this, best movies of 2009. The thing that you just see here, this is actually generated ranked entity list. And in this part, they explain how they can actually create these generated ranked entity list. If you tell me that, why I talk about it, because to be able to create an entity list, you need to get the type of the entity. To be able to get the type of entity, you will need the attributes. And that's why this section is important. If you assign the wrong entity type, you won't be able to list them. And since you are not able to list them, you won't be able to rank them as well. And in this part, they actually explain, okay, we are able to classify them, and we are able to list them, but how we will rank them. For ranking purposes, again, attributes are important. If I tell you the best children movies, the attributes will change, because best child movies attributes are not same with the best action movies. So everything that there will change. This is about, again, the product reviews and affiliate marketing one more time. Since I have to be quicker, I will need to be a little faster too. And I will need to go another meeting actually. The migraines anyway. So this is about that. And this time I want to show a few things from dear Bill Slavsky. As you see, he also explains many of these things and transfiguration of search. This is important because here basically signs are there that this is the direction that the search and the SEO are headed in, where the semantic web plays a larger and larger role. I have been writing for years about topics such as Google's accusation of meta web, which is something like freebase, and more recently about Google might use the web and database to identify disambiguate different entities with the same names, finding entities, a tale of the two Michael Jacksons. It is a newest article too. And if you read these things, it will be useful. They are like nearly 10 years ago. Why this is not working? It was working. This is about open information extraction. It is coming from WAVI. And when it comes to WAVI, WAVI is something important because basically company WAVI, which is found by Oren Etzioni, they are merged with Google. And
I think this talk will be more informal. You've heard lots of talks. I'm going to try to show 3 demos over the internet, which I'm told I'm connected to. So hopefully it'll be fun.
So
while I'm acknowledging people, let me start by acknowledging the folks in the Know-It-All Research Group. We've been working on information extraction from the web since 2003, both students and faculty at the University of Washington. And I tell it I'm looking for good sushi in Seattle.
These are some, there are some really good examples here.
We'll ignore
when
the
you search for a certain types of entity or something here, they're actually
so often they looked at very narrow domain for the web. This does not scale.
Better and better. They give these relationships or limit on number of relations. Again, I have already written it in terms of validation metadata. It is actually the part that limits these things. So here too we talk about WAVI, and actually Bill Slavsky makes that. I have already included some of these merging agreements. The merge agreement doesn't have a location here, but you can check RaveMiner here as well to check what kinds of entities can be extracted from what kinds of text. These are 10 years of technologies already. It will be useful. Extracting instance attributes from text, because if you get the attribute of the entity from the text, you can get the context of the text. Then you can rank, classify, and also recognize the entity from a different expansion or different dimension as well. As you see here, the system is similar. Text repository we have, instance database. We have 3 types of database here in Google: instance attribute database, instance class database, instance to instance database. Based on these, if the entity is cloxacillin, we get the class antibiotics, then we get class instances ampicillin or oxacillin, then similar instances vicodin, then attribute side effects cause pregnancy, then we have side effects cause pregnancy, and this is the main key attributes for this specific thing. Then we will need to find the values. That's it. It's simplistic methodology, and this is what already you have seen. The important thing here is that according to the specific anchors, documents, and declarations, the probabilities will change, and this is about how we can actually corroborate the information from a web page to another, inconsistent information or corroborating answers. They can actually increase the confidence or they can decrease the confidence. Receiving a first information instance, the first information instance being a first semantic object belonging to one or more first information classes. Identifying second information instance related to the first information instance. Identifying in a graph stored in a memory representing information instances and attributes describing the information instances. First attributes describing the first information instance and second attribute describing the second information instances. This is about corroboration, as I say. And then we will be getting actually multiple answers, and we will need to get all these other parts. You can just read the actually summary, even that will be useful here, but I will suggest you to go and read this detailed description. It will be helpful for you. Then you can go for the claims and the patent will be ending. Maybe I can read this. Information instance can belong to a large number of classes, as I say, because according to the attribute, we will be assigning multiple types there. And some of these types, as I have shown in the subjective attributes, they won't be objective. The thing might be penicillin, and it might be beta-lactam antibiotics. It might be just antibiotic, or it might be prescription medicine or medicine or so on. Likewise, each class can include a large number of instances. In addition, many second information instances can be distributed similar to the information instance. Each information instance can have a large number of attributes. In propagating the attributes, the system can identify which of these attributes to describe the properties of information instance and which one do not. So which class is best and what other similar things should be put inside the same document. That's why entity stuffing is not useful. You should choose the right key attributes first to be able to create a proper content network. And here we talk about this topology of instance attribute graph and what kinds of structures should be created. So this one here, generating query answers. I already explained the constraints of query answers, templates of the query answers based on the semantic triples or entity attribute value pairs or triples, sorry. And you can check this example too. This is one of the longest articles that Bill Slutsky has ever written. The longest one, I believe, is semantic relevance of keywords. It will be useful for you to check as well. Generating sentences in response to factual queries. This is what actually ChatGPT already does. But as I say, there are many aspects here. You see, because if you ask a question like this to the ChatGPT, what will the answer be? Whether it is a penicillin, beta-lactam antibiotics. The searcher might assume this is true. Another searcher might assume this is true. And ChatGPT usually, I realize that it gives every answer as in a summative way, but still you might not need all of them. So that's why actually searching in a free way, it will be better. And here we have this semi-scalable attribute value extraction from semi-structured text. This is actually a research paper that focuses on the same aspect, and it talks about the hard parts of doing these things. And here again we have entity attribute value data structure, and here it actually, the research paper explains what are the results and what are the specific methods that they can use, and all these things are connected to feature snippets one more time. And this is that research paper. Basically you can also download it and read it. It's not that long, as you see, just 8-9 pages, and why it should be used and what kinds of attribute whitelists can be used, or what kinds of feature-based candidate filtering can be used in these parts. And you always remember 3 databases: at instance to or entity to entity, entity to class or type, and also entity to attribute. Then we get all these connections like similarities or other types of things, and then it goes like this. So this one is about Google authorship markup pattern. Basically I already published this, but this is important because authorship is also an attribute, and this attribute will be reflected on different types of links, like social media links or different types of articles. If you don't have a proper authorship, these type of research papers will be actually getting and labeling you, and then they will be perceive you as a low quality. That's why I try to have a unique authorship to keep yourself safe, and that's why algorithmic authorship is important, as I have explained in this case study with the results and explanations. I will suggest you to check. So this part here, let me just go faster here. Once we come to this part, method and system for identifying object information. This is from actually Microsoft. It is important to read Microsoft patents, because you will realize that how Google and Microsoft imitate each other and how they try to actually compete against each other in terms of methodologies or in a legal way. And here you will see again we have the attributes: generate matching tuples or matched attribute is key. Even the terminology is actually similar. And if you read these parts, you will see how they are similar in terms of obstacles or obstacles that they are trying to overcome, and what kinds of differences they create. And usually the Microsoft patents, they are very much basic. And I will suggest you to check these things like identify object blocks and elements, select next object block, already selected, extract information, update the database. Database there is actually Satori basically. And it continues like this: find attribute confidence, find the constraints. We already talk about confidence, we already talk about constraints. Only difference here is that maybe they have a different engine, indexing engine, ranking engine, maybe they have one more. And maybe they try to use a different sentence structures or a different thing. For instance, this mathematical formula might change. And feature, function, or contribution, they see them equal. If you read these things, it will be easier to get further. Detecting product lines within product search queries. This is about, as I say, the Google Base. Google Base was a platform that we submit products. I already mentioned the product lines and why they are important. If you get the products and product lines and their connection to the brands, and certain types of attributes for these products, you will be getting the context, and you will be able to create a product graph, which will be useful for shopping queries or review algorithms or review quality algorithms as well. If you read this part, like classify the product, basically product type is the class name, product is the entity, and we will get different types of categories based on the attributes that are assigned to that. And if you read this part, you will see that a more specific example of EAV models one more time. Embedded communication of link information. Matt Katz should be here. Matthew Daniel Katz, he is here. Krishna Bharat is important too. Here actually, this is also important because based on the links on the web page, this is about backlinks, yes? Based on the links on the web page, we try to understand what kinds of a weight or what kinds of an attribute should be seen there, or according to the links that are placed into the here, like link tag, they say, we try to see actually what kinds of attributes are more important. Because here, as you see, we have a value, and that value actually will be helping us. For instance, location information, payer information, or payer. Based on the internal links, we try to actually get certain types of, let's say, attributes for that specific type of entity that is associated with that. And that's why we usually use attributes inside the internal links too. So Google Base here, it also has a patent. Yes, basically Google Base is a platform. Also Google Base has a patent, and how the entities are labeled, classified, or ranked, or generated in terms of data. You can also check this document from Dear Wilslavsky, and length of description, title, label, attributes, pictures, or regency of the offer, or rating of the provider. Provider in this case is the store. Basically, if you want to understand Google Even Merge Center, you can read these things easily. And feature snippets, extracting text from page citations. So in this one too, it's not that different. Basically, we try to actually get the methodologies of Google for finding facts from the web pages, and there are different ways, and there are many research papers here that you can actually use if you want to read. And systems like self-supervised learner, single pass extractor, or redundancy-based assessor, it tries to explain the probability of a valid answer based on different methodologies. It will be useful for you to check. When it comes to here, ranking search results using language types, I already explained it in the article. When it comes to Google's browsable fact repository, I already explained it from the Andrew Hook as well. But if you check this part, it will be useful here because directly actually Andrew Hook explains annotation framework, what kinds of things can be annotated with what kinds of things, and structured data and NLP, how it can be used. Meta web or structured search engine concepts are mentioned here already. And this is the Andrew Hook's blog basically, and secondthought.org. And here actually he explains what kinds of things he did, and Foursquare he also worked with, Google also he worked with, and what kinds of things actually he did inside Google. He explains, and he mentions knowledge graph, as you see. This SEO research is like journalism, as I say. Alternative search query prediction. So this section is important to understand what kinds of attribute can signal, what kinds of other contexts, and what kinds of query aspects can be connected for that specific query context as well. And receive a partial search request, perform speculative search, perform speculative search a few times with iterations, and then they are taking a kind of select, let's say, result selection, provide content related to speculative search result, or try to take actually more and more and provide search based on the completed search query. So it is about actually even bidding system inside the search engine result page features. And if you just check the textual section of this pattern, it will be easier to get the first sections or the first examples here. But this is about, again, actually the attributes, because with the attributes, they will be getting these compositional queries, as I said before. And this is important, deep learning classification to fight web spam. Basically, this is the same. They use ML and deep learning actually to get the, let's say, the web spam as much as possible. If you read this document, you can understand what kinds of systems they can use for getting results and classifying resources using a deep learning. Usually, or deep learning, usually if Google says resources, it is web page or sources basically. And here they try to get the feature. Feature means it is coming from actually deep learning. Basically, it is vectorized output of the deep learning algorithms. And here they try to get the, let's say, URLs, titles, or even if you just go and talk a Google engineer, they can give you a few information. They don't tell you what they do exactly, but they might tell you something like, we just take websites, we put them into the certain algorithms, then we label them, then we move on. That's why I do not think that Google engineers exactly know what they are doing. They just classify, label, re-rank sources, then they check the user feedback, then they do the same thing one more time by adjusting the algorithm, but they don't know exactly why it is like that. They just play with the algorithms. So it requires actually understanding searchers a lot. That's why it requires maybe 15 years of plus experience in Google engineering. And that's why people like Paul Haar, they are really important to give these things in a better way. And Jeffrey Dean is also important. If you want, you can check. And how Google may handle question answering when facts are missing. So this is important because inside this factoid based article ranking, I actually talk about safe answers. Sometimes even if they know the answer, they might actually still answer your questions, because if you ask a question like whether Barack Obama is an American citizen, he is, of course, but at the same time there was a discussion about him, whether he's born in Kenya, whether he was born in United States. It is important to get that according to his born certificate, his presidency attribute might change, like a dependent attribute. So that's why for these type of queries, usually Google was giving answers like Barack Obama is an American citizen. So they take the context in somewhere else. And if the fact is missing, they can use natural language inference, as I have shown in these examples, like duration of the events can be seen, or they can understand attributes or even certain types of values for these type of things. So even if the facts are missing, they can complete these things with safe answers, or they can converge the specific context to another part, basically. The string represents a fact that is absent from the data graph. Search the internet for a document including the template sentence. Template comes from generating query answer patent, and upon determining the internet include a document with the template sentence, infer the fact by generating a series of connections between the nodes and edges of the data graph that together with the first node and the second node. The first node and the second node is like first information object, the second information object for inferring the attributes from the documents. Remember, it was somewhere here, is configured to represent a fact, a series of connections defining a path in the data graph from the first node to the second node. For example, a node may correspond to a fact describing a parent-child relationship. For example, baseball player Bob Boone is the son of baseball player Ray Boone and the father of baseball player Aaron Boone and the Brett Boone. According to the data graph, may include an entity as a node corresponding to the Boone, which may include an edge for a parent relationship directed to Ray Boone and two edges for child corresponding respectively to Aaron Boone and to Brett Boone. The entity or node may also be associated with a fact or an attribute that includes an edge, and between Boone and as a node and as baseball as a node. Alternatively, the node Bob Boone may include an attribute, a property like occupation set to baseball. However, there might be no edge in the entity or graph as a whole corresponding to the grandparent relationship. So that's why repeating even redundant facts is important in semantic SEO. That's why I'm telling that you will need to structure everything, you will need to create it, or you will force search engine to infer it. Therefore, the relationship between the Ray Boone and the Aaron Boone may not be shown in the graph. However, the relationship between the Ray Boone and the Aaron Boone may be inferred from the graph so long the question answering system knows the answer. But the important thing here is actually completing these things as much as possible, and joint distribution also. It is actually a presentation, but you can get the joint distribution, something like distributing or joining different answers together and distributing them. This is what actually Niva search engine does already. Semi-structured question answering system. This is about incomplete answers, incomplete text or incomplete queries, and this person is important too, and his last name is really interesting. And in this part too, if the question is not completed properly, search engine will need to complete the question, but to be able to complete the question, they will need to get all the possibly related documents, and they will need to get the partially matched strings with that question, then they will need to get the subordinate text for these questions or following text for these questions as an answer. then they will need to get to all the most possibly related actually attributes and entities. They want to create a graph. The best graph will be chosen. And when it comes to the best graph, usually if the distance is shorter, it is best, and the confidence score will be higher. I'm really tired, sorry. Since I am behind the schedule, that's why I'm trying to be quicker, sorry. Segmenting printed media pages into articles. Segmenting section is important here. It basically explains actually what kinds of attribute and entity pairs can be gotten based on, or can be got, sorry, based on the web page sections. There is actually a good presentation for that here. So this is printed media, and according to the printed media, they understand that different titles are for different web page sections. Not web page exactly, but if I turn this image into a PDF, it will be a web document, and then they will try to understand that, okay, this title or heading is for this part, and they try to get that this title is for this part. But what will happen if this thing is also relevant to here? If they don't get these segments properly, they won't be able to understand the context of the document overall. And if this thing here, it is also for this, and or all of it, they will need to get it in some way. And to be able to get that, they will need to actually understand again the entity and attribute pairs, and then they will be able to actually connect these things. For instance, for these are orphan blocks. They are not connected, and this system also can be used for web pages in terms of the categorical syllogism. Categorical syllogism means that actually it is transfer learning. If something works for PDF, it will work for web pages too. Let's use it. Simple. So read it. And learning synonyms, object names from anchor text. I already explained this 2 times. I won't go further for that, but imagine that we use attributes for internal links, as it is mentioned in this one, I guess, from the methods. When I mention it, actually, I mean this. It is connected there as well. Sorry. Here. And when we look at the fact extraction, normalization, and visualization, I will suggest you to read this document as well, especially try to understand normalization of a fact, how it can be normalized. And here, browsable fact repository, we already have read Andrew Fouque, as you see. Names are even similar right now. If you watch me all the time, you can check, especially his work here. You can also read these things. If a document does have at least a first predefined number of seed facts, a contextual pattern associated with the seed facts is identified, and other instances of the content in the document matching the contextual pattern are identified. Contexts have certain types of patterns. Remember what I have told here: contextual flow, coverage, and vector. These 3 things will be used there. It is about that. Attribute entropy as a signal in object normalization. And basically here we have a kind of entropy for every attribute. Then we are selecting facts for common 2 objects. For each common fact, determine a match between 2 fact values based on match measure. Determine whether 2 objects are duplicate object based on the entropies of the matched common facts. So imagine that in one of these patterns, we are trying to understand the type of the entity. Here we are trying to understand whether these 2 entities are same or not, so that we can actually assign the same object ID or a different object ID as here. They are completing each other. When it comes to the here entity display priority in a distributed geographic information system, so I won't be able to read everything here, but if you check these parts, you can realize that certain types of entities and attributes, they might change their pairs or importance according to the geographic information. That's why it is a little bit important. At the same time, query phrases, they might need, or they might mean different meanings according to some of the connections. And Google's place rank and interestingness. Interestingness is important, and it is really an important attribute for ranking. Google Lambda algorithm, I will explain it a lot in the future, especially in the course, and some sections I will mention that. It is also, for instance, Lambda uses 4 main criteria, and interestingness is one of them. The second one is groundedness. We can talk about later. But if you read these things, especially entity display priority as in generated rank entity list, it tries to actually understand which entity should be used first. And here we actually need to get the attributes one more time, because whichever value is higher for that attribute, that entity will be ranked higher as well. Okay, and here we have, let's check this. Proactive distribution for result optimization within a hierarchical architecture. And this is not directly from Google as much as I can remember, but it focuses on the same or similar, let's say, sections, and that's why I can tell even the diagrams are a little different. But let's assume that the hierarchical data structure there, it is something that will be helping you, because semantic networks, at the first we assumed that every semantic network is hierarchical. Then we realized that they are not hierarchical, and because we have something like ontology. But the hierarchical architecture here, actually, for result optimization here, it will be useful for you to get what kinds of hierarchy can be assigned to the specific context, because in certain types of context patterns we also have context hierarchy. And which sections of your web pages might actually search engines ignore. This is about main content and also boilerplate content. That's why I also have shown you that printed media sample, because web page segmenting is something important, and here we can use like sections to be ignored may be referred to as no recall sections, and the search engine crawling program may ignore sections of pages that have been marked by webmasters who have used a robot's no content class in HTML tag around the specific div, or links within no recall sections may be followed by the search engine crawling program to discover the new content, but it might not be used for further relevance, for instance. So this is a kind of explanation. Just read it for getting an idea. It is important to get this because when you get these, or let's say entity is here, we have attributes, we have other classes, and we will need to create a certain types of web page segmentation so that important parts can be seen and used in a better and faster way by the search engines. If web pages are not clear for HTML normalization, it will be harder for search engines. Even Martin Shiplet mentioned actually centerpiece annotation publicly even once, to tell that there is a section that actually signals the context of the and purpose of the web page based on segmenting. Improving quality of search results by avoiding indexing sections of pages. In this one here, this is from Yahoo. Basically, they try to actually get some of the web page segments and they try to actually ignore some of these sections. And here we have some examples. This is a basic patent, but if you read it, you can understand what kinds of segments of the web pages can be ignored and based on what. Even background color differences, font family differences, font size differences can affect that. So these are not directly about attributes, but usually we put different attributes to the different parts of the web pages. And if these parts have different types of annotations, they might be ignored or they can be weighted less. Short text conceptualization using probabilistic knowledge base. So let me explain this part in a good way. So when it comes to the probabilistic knowledge base, in a few times I mentioned object and fact ID. I mentioned multi-value attributes. I also told you that semantic networks are dynamic. So even in my creating semantic network section, at some place here, the structure, it should be, no, maybe constructor. Let me just check, because components of the semantic networks, I remember that I have given them at somewhere here to explain further in the knowledge based trust context, maybe in the long form or somewhere. It should be somewhere in terms of constructing these things or destructing these things at the same time. Maybe, I guess I'm not able to find it directly at the moment, but maybe in the future I can check it one more time. So anyway, you can also check these explanations, by the way, or suggestions for you. It will be useful. And since we come to the end, I am a little bit slower. But probabilistic knowledge base means that the attribute entity pairs or their explanations or their values, they are not static, they are not fixed. They will change their values according to the document statistics or according to the authority of the sources or according to the richness of certain types of documents. This is about semantics. And at the same time, here we have examples like apple heat quarter. This is entity, this is attribute, we will have an attribute, or apple smell color, which means it is a fruit at the same time. The values might change, but according to the attribute connections, we get the type of the entity as well. And based on these connections, we try to rank these things based on a taxonomy and ontology. And here we have examples, list of entities. If the person is a politician but also a stakeholder, we will filter these things based on that. So we get the specific relevance based on a probability. And here if we have the term cat and we have WordNet hypernyms, I already explained to you the importance of lexical semantics or lexicosemantics. Then here we have Wikipedia categories for them, free-based types, which is bought by Google. Then we have pro-based concepts for them, pets, species, mammal, small animal. And you will need to use all these contexts based on your website's purpose as well. An instance of these or attributes are these. So here we try to change the values and also we try to get the correct entity type based on these things. And you can check how these sections might be helpful for you to actually improve your structure even further. So as we may think, I can also talk about this because the search or digital search, it exists nearly for 70 years. The information retrieval, it started with the Cold War and we had to understand what the enemy thinks, what the enemy is trying to do. And to be able to do that, if we have 3 million words inside the enemy communication, we try to understand what is the most important part there and what kinds of codes exist inside it. If we are able to get the important parts of the documents, or not just important, but also if we are able to click or crack the meaning of the password like sentences that they use, we are able to actually take the precautions. So that's why understanding these things is about how we think as we may think. In the beginning of this video, I told you that think these things as a brain exercises. If you think like that, you will get that semantic SEO is not just for ranking websites. It is actually about improving your mind exercises, mind capacity. You will be able to think in a better way and you will learn how to think in a way much better way, which will be helpful for you to actually shape your life in a way much better way as well. I would suggest you to read this As We May Think paper from Vannevar Bush, and he suggested creation of a certain types of search engine with this type of actually camera. Basically you think something and the camera shows you the results for the thing that you actually show. This is basically where we are going right now, connecting search engines to our brains as much as possible. And in the future we can see all these results, possibilities directly inside our brains. And I believe I can show you actually a pattern for that. Let's make the end of this video a little bit interesting. So as you already know, patterns, they are a really good, useful tool for business analysis. Maybe this transmitting data with human body, it should be. Yeah. So this paper here that you see, this is a new patent. Actually, even if the filing is actually old, let's say, I can tell you that it is updated and Microsoft keeps it. It is about methods and apparatus for transmitting power and data using the human body. So imagine that we directly connect Microsoft Bing to your brain and your body. And imagine that you are able to connect to another person and you are able to even transfer the data inside your brain to another human brain. And imagine that we are all like connected neurons in the future. So in my opinion, this is where the search engines and search engine optimization will be going. 13 years ago, Matt Katz told that we will be able to search directly with our brains. And it has happened. Someone from actually MIT, an engineer, he was able to create a tool that connects Google directly to our brains. He is thinking and he is directly search with his brain, then he gets the answer. I didn't put these things into my video because it's a topic, but when I tell you that, focus on how we think, structure your mindset, disciplinize your mind, so that you can actually construct every argument in a proper way, and so that you can actually recognize the opportunities around you better. You can actually articulate every thought you have in a better way, and you can play with the life in a better way as well. You can actually have better moves, and you can actually grasp every fact around you in a better way. You can even increase your memory efficiency as well, or you can even increase your thinking speed as well. So that's why semantics is about that. And if you ask me what Microsoft Bing will be doing with ChatGPT, I fear they will connect these things to our brains, and I believe neural link is about this. and that's why I call it narrow link, because we will be connected to each other in the future. So with this science fiction section, this is one of the longest videos that I have ever published. I hope you were able to follow me until this very moment. So I am really thankful for that. But while I am having migraines, collecting all this information and put them to here as a free and pre-training for our Semantic SEO course is not that easy. And I will suggest you to watch this video repeatedly, because whenever you watch it, you will learn something different. Check these links, check these documents. You will also examine them so that you can understand the Semantic SEO course very much easier too. In the course, I won't dive in theories. It will be purely practical. At the beginning, I will explain the concepts that we will be using in a short way, but even they will be practical as well, so that you can directly go for implementing it. And it will be an active course, which means every module or every different result or every different website will be coming there too. But semantics require linguistics. Linguistics require thinking in a healthy way. Always remember that. So as this shape does, so bye bye and namaste.